Hi, Nate. Good afternoon. Can you hear me?
Yes, we can.
Thank you so much, please. How far, Fasasi, can you hear me?
Yes, I can hear you.
All right, fantastic. Yes, thank you so much for your time. Please, I've made you co-host. I think you can go ahead to comment tutorial. All right, so you can share your screen and then probably take off from there.
Okay, excellent. Good afternoon, everyone, and hope you all are doing great. I hope you can hear me clearly.
Very well, Fasasi. Thank you.
Okay.
Yes, we can.
Okay, excellent. So I'll just get right to it. However, thank you guys for joining. In short notice. Hopefully, we get to pick one or two from what I have to say today. Hope you can see my screen. I hope you can see my screen.
Yes.
Go on.
Go on.
Excellent. Okay, so basically we'll be talking about BEME, which is a Bill of Engineering Management, and it's basically just trying to let us understand how exactly, like when we are on site, how they usually do the bill of quantity. So bill of quantity have different standards, right? But due to the fact that we have quite a number of voluminous stuff to talk about regarding the calculation, I won't want to go into those details. However, one thing you should just know is that there are certain rules and regulations that usually structure the way we go about our bill of quantity. So what do I mean by rules and regulations? Like, we have some standards. If you probably read the we have standard for surveying guys from their end. We have standard from civil engineering guys. We have standard for quantity surveyors guys. Do you get? So those standards are standards that are used that were prepared basically to make sure that things go well when we are doing our bill of quantity. And you can bear me witness that whenever you're working with anything engineering or science related, there are certain rules and regulations that guide us. So let's just get into it. So the first thing you need to know is that when you're trying to work on bill of quantity, you need to understand that we have like 7 to 8 rules you need to know. And it's basically called the principle of management and description. So what are the laws or the guidelines you should utilize? So when we're writing our normal English, they tell us put full stop somewhere, they tell us put comma somewhere, they tell us put semicolon and whatnot. Or when we are probably doing when we're probably using our mathematics, we have to follow board mass, use your BOD and whatnot. So in this case now, these are what we need to utilize when we are trying to work on our bill of quantity. So the first thing is dimensioning your paper. The next is order of dimension. Oh, there's an error here. The next is order of dimension. Apologies, over 19. I had to say it over 19. So the next is timesing, dotting on, brackets, waste calculation, then alternation. Alternation in dimensions. So moving on, please kindly let me know when I'm too fast or when you don't get anything that I'm saying. So moving on, you need to know what dimension in paper means. So dimension in paper means that the number of columns we will be using when we're trying to create our bill of quantity. Just like when we're probably working on when we're trying to do our detailing, or when we're trying to do our, I don't know another example to use, but it is trying to say that, okay, you're trying to do your bill of quantity. These are the things we need to see. These are the areas that needs to be clearly show how you maneuver each ways around your calculation. So you know the timing, the timesing, you know the dimensioning, you know the squaring, the description, and the waste calculation, right? So just know that you need 5 columns, but you don't need the waste calculation like that. Okay. I'm listening.
Just mean your timesing, like what does it mean?
Okay, I'll get to explain those in subsequent slides. Yeah, so I hope that's fine.
Can you come again, please?
said I hope that's fine. I will explain it in subsequent
Okay, no problem. Okay.
subsequent slides. Excellent. So moving on, I wanted to mention that waste calculation is not really important. It's not. There's even isn't really important and necessary, right? So waste calculation is not important, but it is necessary. Why is waste calculation necessary? Because when structure is or a superstructure to an engineer, basically what the engineer wants to see is, or what the client wants to see is how we're able to do a breakdown, how we're able to come up with this particular measurement, how are you able to make this arrive at this particular calculation. So that's basically what the waste calculation is supposed to do. However, like I said, it's not important, but it's necessary. So moving on, you need to know the order of dimensions. The order of dimensions vary from cubic dimension to superficial, which is area dimension, to linear dimension. So cubic dimension is when you're trying to multiply your length by your width by your depth. And we also know that when you're trying to work with area dimension, that's when you're multiplying your length by your width or breadth. And when you're working with your linear dimension, you're just working with your length. So that's that regarding the So now timesing, like Toby John asked, timesing is trying to let you understand that when you're working with bill of quantity, you necessarily don't have to do, okay, a quick scenario is, imagine you're trying to construct a warehouse. Yes, a warehouse in, okay, let me just use a construction. Imagine I'm working with a construction company, and this construction company got the opportunity to construct houses in an estate, right? So moving on, I was told to construct like 15 units of that estate, and I had to create a bill of quantity for that, for that estate. Instead of me having to work to create bill of quantity for each of the units, all I just need to do is use the timesing. The timesing is just going to be, I am working with 15 units in this case, so it will be 15 slash. Please kindly note that slash is important. Why the slash is important is, like I said, every unit or every area of study have their own rules and regulations. So you could have just said 2 times, right? But in this case, you are using definition of multiplication. Then we go to the dotting. What does dotting mean? Dotting is trying to explain to you that and you guys understand that when you're trying to construct, it is either we have more excess material or we fall short of material. So in this case, this dotting is trying to let us know that it is accommodating if you need more materials compared to the normal materials you've calculated. Just like something came up, or we were constructing and there was probably an issue and the cement and whatever were not good enough for something, you did your cube test and it was not accurate, you get to add more to your bill of quantity. Why? You need to keep referencing to this bill of quantity because you need to show your clients, and you need to carry your client along in every process.
Hi, Fasasi, sorry to interrupt you, but
in the
can
case
you
that
please probably slow the pace down a bit?
Oh, okay.
Yeah, someone said you are too fast.
Oh, sorry, I can't see because I'm just seeing my screen. Sorry.
I get.
Okay. So sorry, because I can't see my screen, I think it's best you just probably unmute yourself and
Omoniyi, I think you were too fast for the whole previous explanation, so you might just need to like do a quick recap of the explanation, taking things a little slowly now. Thank you.
Interesting. Okay, no problem. Okay, let me start from here. I guess this works. So basically, what I was trying to explain is, I was just trying to let you understand that when we are working, when we are dealing with bill of quantities, there are certain principles. So it's called principle of management and descriptions, right? So these principles are what guides us to have a proper it's also called taking off sheet. So in this case now, you want to create a document that anybody anywhere in Nigeria can view and can relate to it. So that is why you have to work with these rules and regulations. And the first one is the dimensioning. The second one is the order of dimension. The third is the timestamp. The fourth is dotting on. Fifth is brackets. Then we have the waste calculation and alternation in dimensions. Moving on, we are working with the dimension paper first. So imagine you have a blank sheet and you are trying to do your bill of quantity on it. How exactly do you want to represent your values, or how exactly do you want to represent your dimension, or how exactly do you want to show from the fact that we have a drawing to calculation? Do you get? Bill of quantity is just like I have a drawing aside and I'm trying to calculate for every material I need on that drawing on this paper. So now the first thing you need to do is that you need to have the times in colon. I will explain what the times in colon is in further slides. Then you need to have the dimensions, you need to have the squaring, you need to have the description, and you need to have the waste calculation. However, I said that the waste calculation is not important, but is necessary. Why is it not important? Because not everybody wants to see the basics around your details, right? Imagine you are sending this to an engineer. An engineer already has so the engineer might not need to see how you're able to arrive at each of the values you are using, or each of the dimensions you are using. So in this case, the client is the one that actually needs to see the waste calculation. Why? Your client, anyone, can be someone working in the oil sector and probably doesn't even understand what that is, but all he or she wants to see is that I want to see what is here and I want to be able to relate to it. So that's basically the concept around the waste calculation. We have the cubic dimension, we have the superficial dimension, and we have the linear dimension. All these fit under the dimension column, which I highlighted here. I don't know if you can see, but which is already on this table. Then we move on to the time thing. So I was just basically trying to explain that the time thing is just trying to let you see that when you are working with more than one unit, you necessarily don't have to calculate for all those units. Instead, you need to calculate for just one unit in as much the same structural elements, and they also have the same dimensions. All you need to do is calculate for one unit and multiply it by the total number of units you want to make use of, right? So in this case now, I am trying to work on so based on this here, I'm trying to work on a 2 units, let me say a 2 unit cubic value, right? So now, instead of me saying that I want to do 10 times 5 times 0.5 in 2 places, all I just need to do is what? 10 times 5 times 0.5 times 2. Note, you are not writing 2 multiplied by, you're writing 2 slash. Like I said, I don't know if I choose what organization, but every profession have their own rules and regulations. So you won't want to send your bill of quantity to, or your takeoff sheet to a quantity surveyor outside there, and the person gets to see that I can't relate to this. So that is why you have to use their terminologies. You have to use what they can recognize and what they can relate with. Then we go ahead to talk about the dotting. So we all realize that when you're on site, you have calculated that things should go this particular way. However, it won't go that way. It is not really your fault. It is probably because there was miscalculation somewhere or something. So in this case now, in a case that I have a construction going on and something happened on site and I couldn't get to calculate and to put things in place for my material. My client needs to know that I spent a certain amount of money. Even if I'm taking the money from my hand, I need to show it on my Excel sheet or whatever my client is going to see. So now I have calculated for just 2 units of that particular dimension. How do I add the 1 unit extra that I'm bringing on board? So how you add it is 1 dot. That is the essence of dots. Dotting is 1.2. So 1.2 is as good as 3. So you won't be multiplying your total dimension by 2 again. You'll be multiplying it by 3. Moving on, you need to know what bracket means. You need to know how they utilize bracket or when you see brackets in bill of quantity, what exactly is it used for? So the bracket is trying to explain that when you have a description, right, your values or your dimension can be for more than one description. Your value can be for just one description. So this bracket is trying to let them see, I have so many values. However, all these values are aligned to just this one description. That is the essence of you using brackets. Then we go to the waste calculation. So the waste calculation is just trying to show you that, okay, I have my, okay, let me assume that I need to cast for a length of 10 meters, breadth 10 meter and 5 meter, and the depth should be 50 or should be 0.5 meter, right? So now, if I have this drawing on ground, how am I translating it to what is on my bill of quantity? That is why you need to show that under your length, under your waste calculation. So now, basically what I'll just do is that I'll go to my waste calculation, and the advice I have when you're trying to do your bill of quantity is the first column you need to work with is the time column. Then the next column you should go to after your description column is the waste calculation column, because it's your waste calculation column that is going to help you know that I actually got the value right. I've actually calculated the basics around what I want to use. Then you transfer the values you get within your waste column to your dimension column. Do you understand? So moving on, the length column, the waste column is just the waste calculation column is just trying to let them see that, okay, this is the length of the whatever I'm using, this is the width I am using, and this is the depth I am using. Then you bring it back to your dimension column. There are cases when you probably have to do more calculations, which you will see as we move forward. Then we get to how exactly does a substructure BEME, how exactly do you have to go when you are trying to construct or when you are trying to work with a substructure bill of quantity. Now, the first thing you need to do is that you need to know that when you are going to a particular land.
Sorry, Fasasi. Yeah, just a clarification. Earlier, somebody asked if bill of quantity is the same as BEME. Like, can you break those two down, or because you are using them interchangeably?
Which one?
Bill of quantity and BEME, are they the same thing? Because you've been using them interchangeably.
Bill of quantity and
BEME.
I
didn't get that.
You have been interchanging BEME and bill of quantity. So are they the same? Are they referring to the same thing?
Oh, is bill of quantity the same as BEME?
Yes, that's the question. Yeah. So we're asking you.
Are you asking if bill of quantity is the same?
It's the same as BEME. Yeah, that's what we're asking.
As BEME.
Yes, that's the question.
That's the question.
Oh, excellent. Okay, excellent. So, like I was saying earlier, right? Please, when you have questions, just break in. I am not seeing the chat box, neither am I seeing any other thing except my slide because it is on full screen. I guess we are good. So thanks for you for prompting that. So basically, how it works is bill of quantity is prepared by the surveyors, the quantity surveyors, while BEME is prepared by engineers, right? So engineers, it's just like engineers are the ones trying to verify the bill of quantity you have on ground. Do you get? So while I have been using them interchangeably, is that it is the quantity surveyors that actually creates the bill of quantities. However, we are working with the area of engineering in this regard. So we are not the quantity surveyors. We are the ones preparing BEME. So BEME and bill of quantities is the same thing. Do you understand? But those that are utilizing it are different. Quantity surveyor is different from an engineer. We are functioning as an engineer, while those ones will be functioning, not those ones, apologies, while the quantity surveyors will be functioning as bill of quantity. I don't know if you understand the relationship and discrepancies.
So sorry, another question. Is BEME now like an acronym? And if it is an acronym, what is the full?
Yeah, BEME is an acronym.
So what's the full, please?
full whatever for BEME. I can't remember writing it, but I think it
I
was
think
in
it is Bill of Engineering Measurement and Evaluation.
Oh, excellent. Yeah, so I can't remember, I didn't remember writing. So I guess we are good. BEME is an acronym. So can I proceed?
Yes, please.
Okay, excellent. So moving on, we need to know the steps to put in place when you're doing our bill of quantity or when we're doing our payment. Let me just use payment so I don't have to keep doing the back and forth. So we need to know the steps to put in place when we're working that payment. So now, the first thing you know is that when you go to sites, there are different cases, right? We have different, we get to see different conditions when we get to sites. In some cases that when you get to sites, you are getting to see what will I call it? You are seeing a water area that is, I don't know, Yorubas will say area, I don't know what's called in English, but you can get to a location and you see that it is full of water and the soil is very bad, just water. You can get to a scenario that you are seeing a dry land, but you have to probably cut the grass or something. You can get to a site that all those things are on ground. All you just need to start with is excavation. They might even have done the excavation for you, right? So moving on, in this case now, if you check the question, but let me just explain the procedure so we can check the question later on. In this case now, we are working with a virgin ground that I am going there for the first time to have to put this on ground, to have to like construct on it. So the first thing I need to do is I need to clear my topsoil, just like cutting the grasses. Then when I clear my topsoil, I'll have to proceed to, after clearing my topsoil, because the main goal of doing this is because I want to construct a foundation for my generator house. Do you understand? So now my generator house needs a foundation so I can put it on. I am not working with the superstructure, I'm working with the substructure. So the first thing is that I clear my soil, then I go ahead to what? I go ahead to excavate the foundation. So why am I excavating the foundation? I'm basically excavating the foundation because I want to see the working area and the working area that I'll be placing my footing and whatnot on it. The next thing is that I provide strut and plank support. So you basically, we don't use strut and plank support here in Nigeria, probably because of how we were trained, or probably because of some bureaucracies. However, if you actually want to work properly on a site, it is appropriate that you you put in place strut and plank. Why are you doing that? When you excavate, there is already a soil interaction, like a soil surface interaction, and you've gone to disturb the soil already, and that is why when at times when you probably see when they're trying to excavate a foundation, or when they're trying to excavate like a soccer way, some areas of the vertical surface we get to start pulling off. So why this strut is important is it helps you to stabilize your soil for the main time, so it doesn't have to be pulling up along the line. And after you're done with that, you go ahead to level and you compact your soil, because your soil is just there. So you have to level it. After your excavation, you have to level it well, make sure it's looking good. Then you compact it so that it will be able to carry the load you're bringing on it. Then the next is you blind it. After you blind it, you place your footing on it. Then after placing your footing on it, you place your block wall, because your block wall is what is going to bring it out before you now have the opportunity to say, okay, this is where my foundation is. Then you now backfill. You know that when you're probably some of us that witnessed when we were doing construction, right? You realize that after they do whatever they want to do beneath the soil, they use block wall to bring the appearance up to the surface. So when they use block wall to bring the appearance up to the surface, the next thing they will now do is they will now backfill, because the block wall has helped you to see that, okay, this is the area I'm working with. But nobody will know what happened before now. Do you understand? Then when you're done with doing the backfill, you had hardcore. So what hardcore is hardcore is like, I don't know if I should use boulders or something. But hardcore is like like materials that you use to stabilize your soil when you probably have a soil that is not good enough, so to say, and you do your oversight. This oversight, step 11, is not important. It is just like an add-on from the professional side of you. So upper side is basically just you trying to do finishing touches after you're done with after you finish placing your hardcore and whatnot. So now this is the question that we have two questions, right? Question one is what do you call it? Question one is on generator, and question two is on manhole. So this question one was one of those I saw in past question, and the question two we'll be solving is the one that the one in the material is sent to us, that manhole chamber thing. But before I proceed, I would like to pause first and see if there's any other question, or we can digest this and we move on.
Thank you very much. I have a question. Can you hear me?
Oh, yeah, I can. Excellent.
Okay. My question basically is, I say we are solving two questions, but with the way the first question looks, it's as if all of those questions are usually different, maybe in dimension or the kind of thing you are dealing with. So solving these two questions, is it going to be able to cover all of the styles is used to setting, or we have to on our own find our way around those other ones?
Okay, so basically these two questions should suffice. Yeah, I think you just have category of two questions. One is the question on the generator house, and the second one is the question on the map. So the two questions should suffice. We good?
Yeah, all right.
Yeah. Any other question before we proceed? It's actually going to be very heated. Moving on. Listen, I'm stressed, but you just have to move.
Thank you very much. I would like to do step 7 and 8. From step 7 and 8, I would like to say.
Okay, I should re-explain step 7 and 8, so you would like to see it.
No, don't go back. Like I can't see what it's here. Thank you.
Oh, I actually stopped sharing. Okay, I would comment sharing again.
Okay, thank you.
Okay, block wall, then foundation.
All right, thank you very much. I've seen block wall and foundation.
Yeah, I might share the slide when I'm done if needed. So let's just get right to the question. So basically, this question says, prepare taking off sheets and take off the quantities for the items of work for the construction of substructure for 15 generator houses shown in the figure using the following specification notes provided. So the specifications are: number one, 150 mm vegetable soil to be removed and deposited on the soil. Number two, 255 mm or 225 mm thick concrete with a ratio of 1:36, as good as 40 millimeter aggregates in foundation.
What is 5.0?
What is what?
Like you're mad, dude. And I civil engineering practice now. What you having on Monday? Oh.
Can you please mute yourself? Okay, thank you. So, okay, thank you. So the next is permits me. This is supposed to be 300 mm hardcore, but typographical error when I was jotting down. So it's 300 millimeter hardcore bed. Then the next is 150 mm floor slab with fabric mesh reinforcement, and make necessary adjustments for the earth filling. So that's the question, and this is the pictorial representation of the question. Hope you can see it. So this is going to lead me to open an Excel sheet that I had to do the calculation, and we use
the question, I beg.
I should go back to the question. Oh, okay. Sir? Okay. Yeah.
All right, thanks. Continue.
Okay, so can I commence?
Yeah.
Okay, so I think a quick advice is you can just kindly screenshot the question and the pictorial video, because we will have to be doing some back and forth on checking the view and checking the Excel sheets. So I would share full now, so you can probably take a screenshot, or if you have the question, you can just check the past question.
Fasasi, can you please take it back a little bit to the question? Just a few seconds.
The line is breaking. I don't know if it's me or you.
I'm in motion, that's why, but you're good. I'm good now.
What did you say? I can't hear you.
I'm good now. Let's continue, please.
Oh, okay, excellent. I have to stop sharing this, then go to the Excel sheet. We got okay, this is the Excel sheet. So let me just I have to share it here. Let me just share this one. Okay. So so here's the calculation for the what do you call it? For the generator house. So yeah, let's begin. The first thing you need to know is that, like I explained when I was trying to tell you about the the land thing, and when you go to virgin land and whatnot, you have to clear the land first, Abby. So where are you clearing? What area exactly are you clearing? What is the what's the length, what's the breadth, what's the depth, Abby? So now permit me, but I think I have to like split my slides into like the Excel sheet and the Kini. So please just try to work with that. Emma Bino.
Try zooming into the Excel. Okay, you're splitting your screen.
Yeah, I have to split my screen so you can be able to see the diagram. Okay, go to the next page. Okay, excellent. So I would enlarge this first, then okay. So now let's work with this first. So basically, the first thing is that we're trying to do our clearing, right, for the vegetation. You know, I already said earlier, I said that when you're doing this bill of quantity thing or BEME.
This is not clear. I can't see anything. It's blurry.
Yeah. Which of them is blurry? Is it the picture or the
both?
Both. Yeah. Is it the same for everyone? Is that how it is for every other person?
It's clear on my end.
Yes.
Can others see it clearly, or it's just from Toby John's end?
From my end, yeah, I can't see it, so.
It's clear on my end.
It's not clear on my end. It's clear here.
So I think it's network-ish. If it's
all right,
clear.
fine. Don't worry, it's clear now.
Okay. Okay, excellent. So moving on, the first thing you need to know is that you're trying to clear your so like I was explaining earlier, I said that when we are trying to create the BEME, we need to first work with our time sync, right? We've already been told that we are working with 15 units of generator house. So that means automatically all your values need to be multiplied by 15 to get the actual number for everyone. Then moving on, we now need to know, okay, for the vegetation, how exactly are we doing the land thing? So I am working with the land of normally working with is 300
Good
by 500.
afternoon, sir.
We need to create like working area. You'll be able to use to maneuver your store. So in case that am I too fast or something?
Just like a breaking transmission, I think your network actually interrupted.
Oh.
Yeah, like just like pause for like some minutes. Just go back and start again. Apologies.
Oh, it's fine.
Yeah.
Okay, no problem. So basically, what I was trying to explain is that when you're trying to do this, the first calculation, which is the clearing of the area, right? You'll be working with the length times breadth. Normally, you know that you're working with, like you're trying to construct a generator house of 300 by 3,000 by 5,000 mm. But you need working area. I think it's working area that it is called, like space for you to maneuver your stores and put things in place and whatnot. So you are not choked when you're beneath the ground putting things in place. So now, in this particular question, we're told to use a working area of length 225 mm on both sides. So the length we will be working with is 500 plus 225 plus 225. That makes it what? 5,450. Are we cool? Is that fine?
Please
That's
come
the
again,
length.
though.
Come again.
Come again.
Okay, so what I was trying to explain is that we are trying to clear the land surface, right? So it is going to be non-economical if we say we want to clear all the land. It's not needed or necessary. So all you need to do as an economical engineer, just go and clear the portion you need. And the portion you need normally should be 3,000 by 5,000, right? But saying that when you are constructing, you will need some space. You can't just say you want to construct within a small whatever and it will be the accurate value. So the space we are using in this regard, based on the dimension we're giving, or based on the dimension the engineer was able to give us, is 225. So we need extra 225 on both ends. So that is why I will be clearing the length of 5,000 plus 225 plus 225. While my width will be 3,000 plus 225 plus 225. I guess we are fine now. Can I proceed?
Yeah.
Okay,
One
excellent.
question, please.
Okay, shoot.
This 225 we are adding, plus both the length and the width. Are we giving, or is it constant?
Yeah, we're giving on.
So I will be giving every time, or that's what we use when we're not giving at all.
We'll be giving actually. We'll be giving. Yeah, that's.
So it might not be. It might be 350, might be 250.
Yeah, but I think based on all the questions I saw, 225. That's what he has given us.
Okay.
So yeah, what will give us? So let's move on to the next. So now, I've been able to get my width and I've been able to get my my length, just the normal way. But my calculation was different. My calculation representation was different. Not that it is different from the normal Kini. So now, what I did was that notes, like I was saying that there are some terminologies we need to use, right? In this case now, I wanted to tell them that I'm adding 225 in two places. So instead of me telling them I'm adding, I should have just used plus, normal basic mathematics, and don't go through stress. But I had to say add spread. That's the word they use, add spread. So moving on, I could have also said that 225 plus 225, but what I did was that I did 2/225. What does 2/225 means? 2 times 225. Then I did my addition. I guess we are good. That's just normal basic stuff. But that was me using the approach they usually use. We good? Can I move on?
Please quickly continue with that waste part.
Oh, the waste part, Abby. Okay, so the waste part is trying to explain how I get each dimension. So for the first one now, the length of excavation, Abby, or the length of clearing. So why I use the length of excavation is that's the area of clearing. Do you understand? So it's basically me just trying to cut the grass, not me excavating to the ground. Because if I'm excavating to the ground, I'll have to recognize the depth. Do you get? So now the point is the length here is what? 5,000 mm plus 225 mm plus 225 mm. But when I'm trying to represent this under the under my bill of quantity or BEME calculation, I am showing that what it is add spread, not normal addition sign, because that is how they represent within from their own end. Then the next thing is now 2/225. Why is it 2/225? I could have said just 2 times 225. I could have just said 225 plus 225. But in this case, I use 2/225. Why? For proper representation. Then I do the normal addition and I am good. We cool?
Yes, right now.
Okay, excellent. So that was the same thing I had to do for my width. So width is what 3000 by 225 by 225, and we get the whatever. So now we now need to go to the squaring area, right? So I said that after you are done with that one, it is best to now come back to dimension. So I'll come to that. I came to dimension now. So I wrote the value for length. I wrote the value for breadth. Normally, I could have probably added the value for depth or height if it was needed, or if we needed to put that in place, but we don't need it. Then the squaring means the calculation of everything. I basically just use Excel straight up, so not to waste time. That means the multiplication of 15 times 4.5.45 times 3.45 and give me my answer. That's the total I'll be needing, the total area I need to calculate for everything that I'll be working on for the 15 gate houses. If I have to clear them, that's the total area we'll be working with.
Is there any where we're writing total area besides 3.45?
What do you say?
Is there any reason why we're writing total area besides 3.45?
Yeah, that's the total area is already showing the what they call it. That's under the squaring column. So you need to show your squaring column. The squaring column is what shows you how the total calculation of each of your breakdown dimensions. Do you get? Because it is actually the squaring you are using, not the dimension, not the times thing. No, everything is useless. The most important thing here is squaring.
Fast cool. Can you hear me?
Yes, I can.
Okay, and for on the squaring column, do we take
your line is breaking? Can we communicate one by one?
Breaking. Fast cool. Can you hear me?
Yeah, I'm listening.
Me, can you hear me? Hello?
Yes, I can. Two people trying to communicate at the same time.
I think the person's network is slow. I can't hear me. So for this trade we got, I did the calculation on my calculator. I'm getting 2 point something. So like, do we round up and we take into account the decimal place?
Oh, valid question. Actually, me, I just use my Excel to do round off. But I don't know. I never had a reason to think of that, right? But just to be on the safe side, I think it's just best to do 2 decimal. I'm not sure if I'm being honest, because I didn't have a reason to think of that. But we can do 2 decimal places, so we don't round off and due to significant error.
All right. Thank you.
Thanks a lot for pointing that out.
Okay, me, can you hear me?
Yes, I can now.
Please, what's the value you got after you multiplied the dimension for length and breadth?
282.4.04.
Right?
Yes. Oh, note.
Please,
I didn't just multiply.
Yeah,
I didn't just multiply the length times breadth.
I
multiplied.
you should walk me through that.
Okay, yeah. So I multiplied the length times breadth times the total units, 15.
15, okay.
Do you get? We are doing this for 15 different gate houses. So I needed to multiply. That's why I was trying to explain that times in earlier. So times in is just trying to like say that okay, you don't have to do your calculations one by one. Instead, you multiply.
Okay. I understand you now. Thanks. Yeah.
Excellent.
God bless.
So can we move to the next one? So the next one, so basically, like I explained, after you are done with what's up?
Like, I've seen you already scrolling down. Like, are you not going to talk about the description or something?
Oh, sorry. Thanks for pointing that out. So basically, the description was given in our question. If you check the question, they said 150 mm vegetable soil, right? So to be removed and deposited on the site. That was the description they gave us. So this is just basically doing further description, right? So the one that is actually needed is this description up here, which is what was given to us. That was how we could know this is where we are starting from. Are we good?
Nee.
Yes.
Can
Yeah.
Yeah, please, for the sake of our network is lagging or making your Excel sheet blurry. Can you hear me?
Yeah, I can hear you.
Oh, who's this? Can you read it out for the sake of those who, because my screen here, I can't see the description well. So
I think this
is not good enough. It's blurry.
If you can send this file.
Okay.
If you can send it already now, so we follow through as you are.
Please send the Excel file, please, to the group chat.
Yeah.
Okay.
Send it now.
Thank you.
I will do that now.
I want to stop sharing your screen for that.
No, I'm on it already. It's fine.
Yeah.
Oh, wait. What is this thing? Sorry, I'm coming, please. Let me look for it. Okay, so I will just drop it right away. It's loading already. I guess you've seen it now. Okay, excellent. So let's proceed, please. So are we good? We can proceed, right? Because there's no time, and I think we have like one other ones to because there are still some technical ones.
Yeah, shoot.
Okay, so the second one, we were told that we should. So I was explaining to everyone then that okay, the first thing we are doing is that we're clearing the soil. And the next thing is that okay, we're trying to excavate the foundation. So we're trying to excavate the foundation. So excavating the foundation is going to come with what? It's particular depth and particular length and particular what? A particular height. No, depth is the same thing as height, sorry, and particular width. So now, if I have to go to the value, so the time thing it's still the same thing. But now the volume of excavated soil, that's the volume of the soil I want to excavate. The length in this case, now, we'll be using the length of trench. So now, why am I saying we are using the length of trench? Normally, you know that when you try to construct, when you try to start your foundation, the first thing you do is you excavate the total land, like excavate everything, so it will be looking like 4 corners.
Sorry.
You are lagging actually. Yes.
Can you hear me?
Yes, I can hear you now.
Hello?
I can hear you now.
Okay, can you hear me now?
Yes.
You sent the Excel sheet. I thought that was what Wally was saying. If you can send the Excel sheet, because my network is not so good, and the Excel sheet is blurry, which is the solution sheet, so that I can follow well.
I sent the Excel sheet.
You know what I mean? You sent the PPT. Okay. Maybe
have you seen it?
I've seen. Okay. I've seen, oh, sorry. I'm sorry. Thank you.
Okay.
Thanks.
My pleasure. So moving on, I was trying to let you understand that okay, we are trying to excavate a certain area, right? So now the first thing you need to do is that you need to know the length you are working with, the width and the depth. So now the length is going to be the perimeter of the Why are we saying trench? Trench is basically trying a foundation. You're excavating in total that you need. Like you won't, because that is where you actually need to blind. You don't need to blind everywhere on your soil. So now, why we are working with the that's basically why we're working with the perimeter.
Fasasi.
So now the first thing you need to know. Yes.
Fasasi, sorry, you broke off a bit. Can you like just recap a little?
Oh, okay. So I was trying to explain that the first thing is that we'll be trying to like know the length, the width, and the depth we are working with, right? So now, in terms of the length, you guys know that we actually had to calculate one length above there, but we won't be using that same length here. Why? We are calculating for the length of trench, not the length of the excavated area. And the length of trench is trying to show you that, okay, even if you excavate as big as whatever, we are still working with a certain area, or we are still working with a certain position. So now the length of trench or the perimeter of trench, it's with what can accommodate for that, right? So now the first thing is that what is the total length of our excavation? 5,450 millimeter. What is the total width? The total width is what? 3,450, right? So that is just from year to year, Abby. So now, if I now want to do the other two, that will just be multiplied by 2. So you guys see that in front, I added 2/ that answer. So now, when I did 2/ that answer, I was getting 17,800 millimeters. But I am not using this total area. Like now I was saying that you just need to excavate the part you need when you're dealing with the trench. So I would have to remove this 225, 225, 225 away. So me removing this 225, 225, 225 away is now me trying to what? Say, now I'm coming to this. Okay, it's now me trying to say 4 times 225, which is equals to 900 minus the 17,800 I have above. So I'll be having what? 16,900. So that is, which is 16.9 meter. So this is what? The length of the trench we are working with, or the length of the length of where we want to place our foot in. That's 16.9. I hope this was explanatory enough. Because we'll be using this value moving on, so I don't want to go back.
Sorry, I missed.
Okay, thank you. Okay, Nii, sorry to take you back. Previously, you said that while computing this sheet, that we use add instead of like normal symbol of addition. So for this second one here,
I did it, Abby.
Of trench. So is that correct? Or?
It's not correct normally, but I just wanted to do whatever I wanted to do and get out.
So normally we should just
normally add, yeah.
Okay,
yeah.
Thank you.
Yeah.
Yeah, thank you. So my question, sorry, Nii, but where is that 900 coming from? I think I lost you there.
Oh, okay, 225 times 4, like this small extra that we had adding before. We are now removing because we don't need them again for the trench we are trying to excavate.
225 times 4 is giving you 900, and 4 times 225 is 900. Is that not 0? Like the last one, you actually did 4 times 225 minus 900. Like, where's that 900 coming from?
Oh, no, sorry. It was when I was trying to impute. It's basically me trying to show you that 225, let me do like this. So why some of these things are showing like this is because I had to type them into Excel. So Excel didn't give me some of the leverage I wanted. I hope it's better now.
Yeah, makes sense.
Excellent. So I guess we can move to the next whatever. So this is the length. Then the breadth. What's the breadth of the footing we are working with? You can just check the sectioning. You found the perimeter now. So now the breadth is 0.65, right? From year to year in meter is 0.675. Do you guys get? Then what's the depth for the excavation?
Sorry, Pastor, can I ask a question?
Yeah, you can.
For that explanation on the length, yeah,
Yeah.
Since we are using our normal dimension, which was 5,000 by 4,000, why don't you just do it directly? Why did you have to first go through adding the 5,450 plus 3,450, then dividing by, then multiplying by 2, then removing the 900 again? Why don't you just use it direct? Did you get me? Fast school.
Hello? Yes, sorry. Apologies.
Can you hear me?
Yeah, I can hear you now. A call came in. Yeah, sorry.
Okay, I said for that calculation of the length.
Yeah.
Why didn't you just, since we are subtracting 900 from it, why didn't you just use normal dimensions? Is that what you're actually calculating, which is 5,000 by 4,000? Why do you have to? Did you get it? Why do you have?
Yeah, I get your point. That's an excellent question, actually. But that there's certain cases when we have to do like basic calculation and when we have to do should I say a conversion or a voluminous calculation just because we want to get the accurate value compared to we just getting the normal length and breadth. So yeah, I also tried it, right? When I tried it, I observed that if I have to do it that way, I'll be doing just 500 plus 300, right? That's equals to 800. 800 times 2, that's equals to 1,600. Abi, 1,600.
Different answer. That's what I was wondering. That it's not meant to be the same answer.
No, it won't be the same answer.
Okay. Yeah. So we should just add the trench first, then subtract 900 from it again.
Yeah. Let's just do that way.
All right, no problem. Thanks.
A pleasure. So now the next thing is that we are this is the length of the trench we are working with. Then the width is going to be where the footing is going to be sitting on, right? And that's what 675 millimeter. So 675 converting to meter is going to be 0.675. Then, excuse me, the depth. So the depth of our foundation is 1,500, 1,500 millimeter plus the 225 that we have here. Abi, the 225 that we have here. However, we'll be removing 150 mm from it. Why are we removing 150 mm? We are assuming that before this footing will be placed there will actually be a blinding, or will be either there's a blinding or we have to, what do they call it? We have to what's the word? We have to backfill for 150 mm. Do you understand? I hope I'm communicating and I'm not getting this confused.
Yes, you are.
Excellent.
Come again.
Your network is not good, but
come again, please.
Okay, I will come again. So what I was basically trying to explain is that when you're working with your depth, right? So your depth is like, okay, the measurement from the ground level to
can you hear me?
Yes, I can. You said I should come again, so I'm already working on that. Excellent. So the depth from 150, the depth from the ground level to below the ground level, right? So now the depth is what? 1,500. The depth for that we need from the beginning without it coming out is 1,500. And the depth for the footing where the block wall will be sitting on is what? 2,500. However, it is recognized that this block wall, this footing here will be resting on a 150 mm thickness of either blinding or backfill that was compacted. So that is why we'll be using, or we'll be removing that 150 from it to get our accurate depth. Are we good? Can I proceed?
Yes.
Excellent. So now the next is now you do your normal.
Thanks, I understand.
Okay. So now you do your normal multiplication. Hey, sorry, this is strange wise. This is strange wise. Escape. I think this one is one that's not solution. Escape. But yeah, let's just move on. So now the first thing is that you do your normal multiplication, you bring your length from here. So the first length is 16.9, the second one width 0.675, and the third one 1.575, right? So you do your normal multiplication. It's the same answer. I don't know why I did it twice, but yeah, you see, this is now the multiplication of what? 1.575 times 0.675 times 16.9 times 15. Yeah, so that's that. So we move to the next one. When you are done, and what do you call it? When you are done excavating, right? What normally the next thing to do is what, to add your plank and struts, right? I told you earlier, I said that we don't do that here in Nigeria most times, but based on this calculation, we have to do this probably because they had to use the standard. So that case now, we are working with a length of 17.8. Why is it the length of 17.8? It's the total length. Because normally we are doing what? We are not working, like when you're placing plank on strut, I don't know how best to explain this, but imagine you have your land now, you've excavated the soil, you've disturbed the soil on the two sides. Now, what you would do is...
Fast go chill, please. Okay. That 269.50, said 15 multiplied by 0.675 multiplied by 1.575. What does it multiply again?
The length, 16.9.
16.9. The length. Where'd you get the length from?
The perimeter of trench that we calculated here.
Okay.
Thanks.
Fasco.
Yeah.
Fasco.
What's up?
Hello, Fasco.
I can hear you.
How do you get 0.675 and how do you get 0.675 and 1.575?
0.675 is the width of the footing, which is here. Can you see it here? And the 1.575, that one is the depth. The depth, that's the 1,500 plus 225 minus the 150. So 150 is either a blinding or it can be a, what do you call it? It can be a that your footing will be sitting on. We good? So yeah, let's move on, please. So the next is now trying to calculate what the strut. So I was trying to explain what strut really looks like rhetorically.
Thank you.
So I don't know if you can see me, but imagine you have land like this, Abby. You have this place, you have this place. These are the two places that you've excavated like this, and you have just this place, right? So now, when you are trying to place your strut, you are placing something within like this to support this ground and support this ground. Do you understand? Can you see me? Let's start from there. Can you guys see? You can see me.
We can see you. We can see you.
Okay, so now you're trying to say that. Okay, excellent. So you're trying to say that you have this space you are working with, you have this space you are working with. So these are the two excavated areas now, right? I am bringing, let me say this is a plank that I am bringing in. So this plank I am bringing in with a flat surface here is what will be helping me support my soil around this place. You won't just put in one, you put in as many as possible. Do you understand? So those planks or struts.
So we can see you have not shared yourself.
Tolu, I think the best thing you should do, try and use the chat box there. Like if you can type I'll read it out to Fasco, whatever question you have, because the way the line is breaking is somehow, I don't know, somehow distracting. We might not be able to follow the class. If you can type it, I think your line is acting up somehow. Just type it in the comment section. I will help you read it out. Hello.
Sorry.
Hello?
Also, in addition to, can you guys hear me? In addition to that, I think Tolu's network is what is making him not see the slide that Fasco is sharing, because I think it is pretty clear for every other person.
No, it's not clear for me. So it's not as if it's clear for everybody.
Oh, okay.
But let's proceed. Time is fast spent already. Yeah? But just try to accommodate the virtual experience. But I hope we can still get the best out of it. So moving on, I was just trying to explain what a plank or what planking or what strutting means, right? So planking or strutting is just trying to show you that, okay, this area I'm working with, place a wood between or place things between that will help you stabilize the soil, pending the time that your soil is stabilized for you now continue or keep on working on your construction. So now the length we'll be using is the total, like the area of the excavation, right? I already told you that we are working with what? 5.45 plus what do they call the other one? 3.45 times 2, right? Length times breadth multiplied by 2. So that's how we're able to get the 17.8, which we calculated earlier. Then for the, what do they call it? For the 0.5, the 0.5 is basically just trying to tell you that the plank you are using has a width of 0.75. You know, the length is what I was telling you about before. But what is the width of the plank? The width of the plank is what? 0.15. So that's that regarding that. That's how I was able to get. Now you do your normal multiplication, you get your answer. Then you do the same thing for your trench.
That's 17.8 up there.
Eh?
17.8, 17.8.
Yeah, I already explained now. 17.8 is the length of the trench, not trench, length of the excavated area. Chibi, we calculated this before that the length of the excavated is 5.450.
I think the question should be that why are we using 17.8 instead of 16.9?
Oh, excellent question. So if you have to, but let me answer the first one first. If you check your calculation, right, which we did earlier up there, yeah, let me just show you. So I don't have to do the calculation. This is it here. So the normal length perimeter, the normal length of trench is actually supposed to be 17.8, right? But because we are working with the perimeter of trench, note there are two cases. Case one is when we're doing the excavated area, and case two is when we're dealing with the trench that was excavated. The trench, like I said earlier, is the area we are working with with no allowance. While the other one is the area we are working with allowance. And if you have to place a plank or something, you have to place that plank in where there's allowance now, because you won't be placing it where you are working with exactly, even though you have to place for the other one too. I hope you are good now. So let me just go back to that side. So now you do the same thing for your, what they call it, for your trench. Do you get? So the trench is also having the same characteristics. So that's why you're having detail to side of trench starting from reduced blah blah blah. No. So now in this case, you know you have to use a different length. You're not using the same length. So this length is now what? 16.9, Abby. And what's the depth of your trench? The depth of your trench is just going to be as good as 1.5, which is the length from here to the soil or above the footing, divide minus 150. The 150 is what we already accommodated for up here already. Do you get? So if you add the two together, you get your normal 1.5. Are you guys getting me?
That 0.15 is a constant value, Abby?
No, it's not a constant value. It's the depth of what we are working with when we are doing this first one. This first.
But please, can you show me on the diagram?
The diagram. See it here.
Can you point to that 0.15 on the diagram? I'm not seeing it. Okay. Thank you.
Yeah, we good.
Is where do you point on the diagram? I can't find it. Okay, thanks.
So,
Frasco.
What up?
The 0.15, I thought you said it was the width of the wood or the plank. So
that was an oversight. No, it's not the width. It's the depth of where the plank you're working on.
Frasco, please, one question. This 0.15 is not the same we subtracted from the slab, which was like, say, probably foundation or blinding or something.
Yeah, it is.
Is it okay?
Mm-hmm. Why it is looking like this is that most times it's just best when you see it on site, right? Because we are seeing it from the section point of view. That's why it's quite confusing. And that is why we are supposedly making some assumptions, which isn't an assumption. I don't know if you guys get it. Because we can't, like, we can tend to prioritize certain things, but there are some that you can't prioritize only if you've been working on several projects around that area. So yeah, let's move on, please. So I already explained how we're able to get the trench, what do you call it? The planking for the trench. Then the next is now you do your leveling and compaction. So now when you're doing your leveling and compaction for the bottom of your excavation, The leveling is going to be within that plant now. What do you call it? What's the word? The perimeter of the trench, because that is where you're actually working with. So that's the only place you'll be doing your leveling and compaction. And the width is going to be what? The width is going to be your 0.65, which is where you'll be placing your footing on. Abi? So yeah, that's how you're able to get that one. Then you move on to the next one. The next one is now what? Is now you trying to cast.
That's cool. Sorry, how do you get 1.35?
So you know that you've already passed your footing, because that's the next thing you need to get. The length is going to be as good as what? Your depth is going to be what? 0.35, which is what is here.
You said how to get 1.35.
Okay.
I said 1.35 is 150 minus 1,500, which is the total length from year to year, minus 150.
I didn't get that. Come again, please.
The 1.35 is the total length below the ground, which is 1.5 minus the 150 that we used above here. I'm coming.
Okay. Okay, thanks. Okay, thanks.
Is that fine?
Yeah, it's fine.
Pascal, I still don't get it. Please, can you point to it on the diagram? Can you point to how you got the 1.35 on the diagram? You said something about total length minus 150.
So the total length below the ground, excluding what do they call it? Excluding this guy, this footing is 1,500, right? So now we know that we already accommodated for 150 before for our trench. So you just subtract that 150 from this 1,500 and you get 1.35.
Oh, all right, thank you.
Yeah. So then the next thing is that you do your casting, because the point of all this is because you're trying to get to the top of the soil, right, or to the top of the ground, to your ground level, so that you do your casting. Oh, there are questions in the chat box. Is this gatehouse or manhole? This gatehouse.
Please, I'm sorry.
Okay.
Okay, then first go, please. The 0.15, is it the 0.15 for the blinding or for that trench above the ground level?
It's for blinding now.
Okay, thanks.
It is the same thing. This thing you are seeing here is cement now.
Okay.
It's cement now. Okay. Yeah, this is hardcore. This is cement, like slab. Can also call it like slab. Yeah. We got, so let's proceed, please. There's no time. So moving on, we need to do the what do you call it? The concrete. So the concrete is going to be the length of that trench we are working with multiplied by what? 0.65675, which is the width, multiplied by 0.225, which is the what? The depth. And then you go to the next one. So the next one now is going to be what? You placing your block wall. Basically, when you're done with your footing, you cannot place your you can now place your block wall. So what's going to be the length of where you'll be working with? Still the same perimeter, right? 16.9. Then you multiply. Then you what's the depth you'll be working with? Because this is from year to year now. So you need to know the actual depth. So normally the depth from year to year is 1,500. Right. So now there is actually a caveat, and that caveat, which I'm yet to discover well, is they subtracted 225 from this. Normally, are they saying that the total length should just be from year to year and we remove our 225, or there's another assumption to it? But I've been trying to wrap my head around it, which I have not discovered. So basically, just know that when you are trying to do the block wall, the depth is going to be what? The total length you have from year to year minus the footing minus the slab, which is what? 1,500 minus 225 minus 150. that was how they could get this. Are we good? Should I proceed?
With first group, 1,500 minus 55 minus 50. That is 1,125, not 1,155.
I'm coming. Let me check computer. 1,500 minus 55. So, okay, 1,500 minus. Wait. Block wall is 1,500 plus 1,895. Yeah. And so it is 1,500 plus 150 minus 225. Deduct concrete thickness. I know that. So you get what I said? It's 1,500 plus this, because this 150. Then you now deduct the, what do you call it from it? The thickness of that footing. Then the next thing is that you do your backfill. So when you're doing your backfill, for this wall, whatever. So you are excavated beyond normal now. So you do your backfill, like the soil to the back. So now your backfill for that area is going to be what? 1.65 times 0.225, which is the width, times, which is the thickness, sorry, times the height, which is what? 1.425. So that's that one. Then the next is now, after you do your backfill, you now do your hardcore. So I said that the backfill is just like you have like a land now. You are done with the box now. So the exposed area behind that box is where you did the backfill, right? So now you are trying to pour your hardcore. Now, if you are pouring your hardcore, you are pouring it inside that box, so that normally we used to use laterite now as for Nigerians. But in this case now, these ones are saying that no, you don't use just laterite to backfill. Inside, when I mean backfill, I'm not saying outside, inside now. So in this case, they're telling us to use what? We should use hardcore instead of using the normal laterite that we used to use when we go to sites. Do you understand? So what's the length of that one? That one is having a length of what? 5. And the depth is what? 3. So basically it's going to be what? 5 times 3. You know the length now? The length of this thing that we're doing. This length from year to year. Do you get? And you multiply it by the number of whatever you're trying to get and move. And last but not the least is your form work. So how will you get a measurement for your form work? Measurement for your form work is just basically going to be the total area of the excavation you are doing, multiplied by 2. So why are you doing multiplied by 2? When you are doing a beam, right, you have to put one plank at the back, one plank at the front, or in front of it. So that's basically why this guy is saying we should multiply it by 2. So when you multiply by 2, you get a total of what? 35.6 meter. That's the length of the 2 sides. So multiply by 15 generators. That's what? 534 meter. And how will you get so this one plank is equal to 3.6 meter. That one is a standard that they had to tell us that the length of one plank is what? 3.6. So the number of planks you now be needing for your total whatever is just going to be what? 534 divided by 3.6, which is going to be what? 148.33. So you can just approximate to 150 to 149 to 150. And we are good. So that's that about question 1. I hope you might not get it. If I'm being honest, you might not get it on a stretch, but you probably have to just go back to the simplest because it takes some level of, let me picturize it. Let me see how it's actually going to be on normal site and what.
Sorry, that's The less floor slab, can you indicate it on the diagram, please? Just for clarity.
The what?
The less, I think you wrote something in the Excel document, the less floor slab.
Oh, the less floor slab I was saying is this one.
Okay. Thank you.
Yeah, so we are good with the generator house. So now let's go to the, what do you call it?
One quick question. The diagram looks like a truss under the slab. What is that place?
What's that? Come again.
The diagram that looks like a truss below the slab. What's that place? The section.
Oh, this is the hardcore. This is the hardcore. Where I point the hardcore.
Then this wall is what? A block wall?
Yeah, this is block wall.
And then that footing below. Okay.
And the footing, and this is the slab.
I have a question, Captain.
Shoot.
So now, all this we just did now, because we're trying to calculate the builder generator house, yeah?
The what?
It's all this calculation we're doing: waist, length, depth, strut and planking, leveling, concrete block wall, backfill. It's because we are doing generator house.
Yes.
So these are the steps we have to take one by one.
Yeah.
So basically, all we just want to calculate the amount of planks we're going to be needing. So that's the final answer I can see here.
Not necessarily just the planks. They are basically trying to get for every other whatever, not just the planks. Okay. Do you get? It's not just the plank we need now. Have you not cast? We've already cast footing now. We've already done block wall. We've already done this, already done that. So it's not just the kidney.
Like for the block wall now, we've got 361.24. Is that like the total amount of?
Yeah, that's the total and that's the total amount we needing for all the 100 and kidney units. Okay. The total area of blocks. So basically, how we now supposed to work is okay. So for the area we will get, so they will not say okay, divide that area by the area of a block. You'll not be able to know the number of blocks they need for. Do you understand?
Thank you very much.
Yeah. So let's go to the next one because of time. Time is fast spent.
Sorry, one last question. Sorry, please, before you go. That length of plank, will it be given?
No, I don't think the length will not be given.
The length of plank, that's what I'm talking about. Length of plank.
It's going to be given.
Is it assumed?
No, it won't be given, but I honestly don't. But why I would say it is going to be given is because I didn't see him give that value in any of the questions. So it is. There are certain things that the man supposedly expects us to know, which we don't know. Do you understand?
Okay.
So
normally
these things that we are doing, we are supposed to be having a kidney with it. Like they should give us a standard table or a standard like BS code, that kind of thing that we should work with. I don't know why they're saying we should do it from top of our heads.
So are you saying we should work with that 3.6 in any question related to this?
Yeah, so work with 3.6, bro.
Okay, thank you.
A pleasure.
Please, Pascal, I missed that. What is 3.6 about? This thing was reconnecting, sorry.
3.6 is the length. It's the what you call the length of a plank.
Length of the plank. I can't find that.
The last whatever on the last kidney on the slide on the what's the name again? Excel, yeah. The last way, right?
So sorry, Fasco. So what you're saying is that we should always use 3.6 as the standard.
That's the standard demand used. So that's the standard that I'm assuming we should use. That's what you used in the solution. Yeah, let's get into this, please. This one is not going to, it shouldn't take us that much of a time because the previous one, we were new to the concept. So that was why it was quite longer for us to create the graphs. So now moving on. This is the one for manhole, right? So Manhole is actually the one he actually sent to us. Yeah, it was Manhole he actually sent to us. So the first thing you need to do, so in terms of Manhole, the question is different. How is the question different? Let me show you. I don't know if anybody have the past question. You can just check the past question. But for my end, let me just check the past question here and just read it out and not share my slide. Let me just read it. So for this,
what year of past question? What year is it?
It is in that 2018.
Okay.
It's nice or something. I'm trying to look for it, but I've not seen it. But that 2019 is very okay. Let me just check this again. So I'll just read the question out so you can understand.
Skip some this thing. Go through your PDF, the textbook, and compare. I need some steps because I didn't want to write it.
Okay, yes. So for the what do you call it? For the manhole, yeah, the specification that was given is manhole cover frame. That's one. The second one is reinforced concrete roof. Who is that, please? Okay, so the second one is now, the second specification we're given is mass concrete. No, the second one is reinforced concrete roof. The third one we're giving is what? Mass concrete, and the fourth is a 255 mm block wall. So that was the specification we're giving here. So let's move on, please. So I hope you can see my slide. Now, so the first thing you need to know is that we were trying to excavate the soil. This time we're not working with the virgin soil. We're working with soil that is probably operational, or we just need to just get there and excavate it. So we're excavating the soil, right? Also, note that we are not doing any times in here because we are not working for 10 manholes. It's just one manhole. They didn't give us the times in specification, right? So now, like I said, the first thing is excavation of soil. So now, when you're excavating the soil, you know you have to work with what? The perimeter, the length, and the depth. Abi? This one's even quite straightforward. So like, you know, the perimeter is going to be what? 225 plus 1,500 plus 225. But note that we have extra 100 by the two sides. Because this 100 by the two sides are what these guys used for their own allowance. So that extra 100 is going to be 200. So when you do your summation, you'll be having what? 2,150 millimeter for the length, which is actually at 2.15 millimeter. And the width is going to be what? 1.65 millimeter, the same calculation. And the depth is going to be, let me just check that one for you guys so we can check it together. So the depth is going to be what? It's going to be I'm coming. Let me show everything here. So that's going to be what? 150 mm plus 150 mm plus 1,500 mm plus 225 mm. So that's that regarding the excavation. So you do your normal multiplication. So your normal multiplication is going to be what? I hope I'm communicating, Sean. It's going to be 215 times 1.65 times 2.03. Get answer. What do you say?
The first row, please. The waist.
The first.
Yeah,
the dimension.
The waist for the first row.
Oh yeah.
Yes, thank you.
I should show you. I should explain it.
Please quickly explain it.
Okay. So like I was saying that the length of the excavation is going to be what? This 150 here plus 225 and 225 plus 100 in two places. That's why I'm having 2 by 225, 2 by 100. So everything will now be 1,500 plus 4,450 plus 200 to give us 2150 mm. Are we good? So you do the same thing for your waist or for your width, sorry. And for the depth, you can always go to the section to sum up from up to down. So now the next thing after doing this is what you do, you prepare preparation of surface material. So when you do your preparation of surface material, you do the 2115, apologies, 2.15 plus times 1.65. So why is it 2.15 times 1.65? 2.15 is the length from year to year. Abby, let's just do the calculation. If you use a calculator, you know that what 1500 plus 225 plus 225. That's 1.95. Abby, plus 200. That's 2.15. So it's just basically telling you that prepare the surface. So what's the surface we are working with? The surface is what? Our total length, that's our total breadth. So that's that here. Then you move on to the next one. You do your concrete. After the fact that you've excavated and you've cleared the surface, you place your concrete on it. What's going to be your concrete? So concrete is going to be the multiplication of your what? Of your depth. The depth is 0.23. What's the width you are working with? The width is what? 2.150. And what's the depth of the area you are trying to deal with? The depth is 0.23. Abby? So it's going to be what? 2.15, which is the total length from year to year, times 0.23, which is the depth from year to year, times the length of the you are using, the length of the manhole you are trying to get from year to year. No, times the depth, sorry. The depth, sorry. That's this plus this plus this plus this plus this. I hope you guys get it. Then you get your mass concrete. Then the next thing is what? The block wall of the chamber. So obviously, when I'm done with the mass concrete, the next thing I'll do is what? I'll try to get the what? How to place this my block walls. This is a block wall and this is a block wall. So I basically just try to create the block wall. And me doing the block wall thingy is going to be block wall in chamber, wall 225 mm. So what is the length I'll be working with? The length is going to be what? I'm coming, let me go to that area. The length is going to be what? This plus, then I mean this, I hope you can see my screen. 225 plus 1500 plus 225 plus 100. Do you get? I hope you guys can get me, Sha. Plus 100 plus 225 plus 100 plus 225 plus 100.
Please, Pascal, please share this Excel too. Can you share this Excel file too?
Check the second sheet. There are two sheets within that Excel file.
Second sheet.
You see manhole.
Okay.
Yeah.
Okay.
So let's proceed. So when you're done placing your block wall, you go ahead to what? To place your
concrete. We didn't get after mass concrete.
Yeah, after mass concrete. I've gotten that one.
We didn't get after mass concrete.
After mass.
Yeah, could you quickly explain mass concrete?
Okay. Sorry. Okay, I get. So now for the mass concrete, we are working with a width of 1000. The width we're working with is the width from, let me just show you from this section. Is the width from year to year. And that width is what? 2.15, Abby. Then the next thing is what? The depth we are working with. What's the depth? The depth is what? 225, but they approximated it to what? 0.23. I think, okay, yes. One thing I just noted is In the man's solution that I sent to us, that one that David, that one that Leo sent to us, the man used two decimal places. After his value, two decimal places. Yeah, because this is his solution. So it's one I used in learning it. Are we good? So in case, I remember I was asked that question earlier. So I think we can work with two decimal places. So yeah, I was trying to explain the mass concrete. So the length of the mass concrete is going to be within year to year, Abby. The height of the mass concrete is going to be within year to year. And what? The width, which it will be having effect, is going to be what? It's going to be 100 plus 225 plus 100 plus 225 plus 100, which is what? 1.65. So yeah, let's move on. I hope you get it. So now I've explained.
Please,
yeah.
can you share the picture for this manhole?
The picture.
The picture.
Can someone please assist me in doing that?
It is.
I can't hear you, Ali.
First for the block wall chamber.
How did you get 1.65?
1.65 is 100 plus 225 plus 1,000 plus 225 plus 1,000. No, 100, sorry.
Okay.
Check that 4.5.
I check what? I can't hear you. The line is breaking.
Go block wall. How did you get 2.95?
How did I get 2.95? Where is 2.95?
Under the waste column for.
Oh, that one was just me trying to arrive at a particular answer. 2.95 is 1.50 plus 450, or let me say plus 0.45, right? Plus 100, which is supposed to be the beginning from year to year. 100 mm, which is as good as 1 meter. So that answer is what? Multiplied by 2. Let me use my calculator so we'll be on the same page. 150, 1.50 plus 0.45 plus 1.
Okay.
It equals 2.95. Aha. Is it fine? Oh. And now it's the same thing now. And now it's the same thing now. Press your calculator, you see what I'm saying. Probably I didn't just show it well on the Excel sheet.
I beg, where you get 0.23?
0.23 is the depth of your foundation below ground. That would be what? 150 plus 150 plus 1,500 plus 225. Oh wait, is it this 0.23 I saying? Sorry. That is what? That's the depth of your footing. Do you get? Yeah. Do you get what I'm saying? I
can't get you. I can't get you.
I said that the 0.23 is what? This 250 mm, 225 mm you are seeing here as the depth of your footing.
Why did you not use 0.23 instead of 0.22? Okay, you approximated it. Okay, sorry.
Yeah.
First,
yeah.
For that block wall. So are you saying that the calculation is 1,500 plus 225 multiplied by 2 plus 1,000 mm?
100, not 1,000, 100.
Yeah, but one converted to meters is 1,000 mm.
Wait. Oh, yes. Sorry. It's 1,000. No, I'm trying to find the perimeter. Sorry. The perimeter of this. Sorry, let me show you.
So account the 225 on the.
Yeah, this perimeter here. Sorry. This length here.
Okay.
Yeah. Is it better now?
Okay, I understand.
So I guess you can proceed. Thanks for pointing that out, actually. Gave me a better understanding of something I was trying to figure out before. But are we good? Can we proceed? So the next is that we're trying to know the reinforced concrete in roof chamber. So what's the reinforced concrete we are working with? So, there's a difference between, concrete needs to be in cubic, right? So you would know that this one is just going to be normal. If they say this first one is just trying to say that the surface you are working with, do you understand? Because if we are working with concrete, supposed to be get, but I had to write this exactly the way the man wrote it in case it is marking guide. Concrete in roof chamber is basically just trying to explain that from year to year times from year
Network is having issues.
Hello, Fasco. Can you hear me?
Oh, sorry, I just realized that I went off. Sorry. Let me just do this. We'll be done soon. Coming. Yeah, so I hope you can see my screen. You can see it, Ravi. Did you get the explanation I was trying to make regarding this reinforced concrete chamber? So it's just going to be the actual length times the actual breadth. Yes, because that is like going to be like a roof. When you mean a roof, like a cover, I think that's the best word. A cover you'll be bringing on board. So that's the length times the breadth of the cover. While the concrete you'll be using to create that cover is this other one that you have to multiply by 0.15. Are we good? However,
No. Please come again. I beg. Sorry.
Okay, so here's the thing. You're trying to create a reinforced concrete cover. I'll call it cover, so for better or whatever. Okay, it's just like you have imagine this is our manhole, right? So now you don't have anything to cover it yet. So now you're going to bring this one from somewhere else. This cover you're trying to bring from somewhere else is this one to cover it. So that is what we are trying to calculate, this area, like the length and the breadth. But imagine this is concrete now. I only calculated the length and breadth of what I'm utilizing. However, I didn't calculate the concrete I am actually using. So that's why I said that the first one is actually just calculating the length times the breadth, while the second one is calculating what the concrete we have to use. Hope you are good. So let's move on, please. The next is what? The next is for our manhole, we need to, what do they call it? We need to subtract this area, like where we have to add pipe. Why are we subtracting it? Where we are adding pipe now, it is not part of our calculation because pipe needs to come on board. So you're trying to get an accurate I should not say score. You're trying to get an accurate measurement, yes, to give your client or to give your engineer. So now this from year to year is 550. You need to remove it from whatever you're calculating because it is waste of material if you're saying it is going to be accommodated. Do you understand? So now the whole you are deducting is going to be what? It's going to be 550 mm times what? 550 mm times what do they call it? Area of circle is what? Pi d square over 4. Abi? Are you guys following me?
Yes.
That's good.
Excellent. So, okay, excellent. Hey, hey, I don't know who that is, but you can just use the chat box. So, okay, yeah, so you deduct, so that's what they meant by deduct all here, right? So you deduct the all. You're having one slash here. The one slash is approximated already, but let me show you the actual value. The actual value is actually 0.34. Sorry, and pi divided by 4. Do you get? So that's the actual value. Do you understand? So approximately 1, but let me just leave it like this. So to avoid confusion. Then the next thing we will now be doing is that we'll be trying to what? Trying to remove this horizontal shortening of roof. So the horizontal shortening, that's this horizontal here, this horizontal surface here. We're removing the shortening, and that's what the length from year to year is what 1.5 times the breadth, which is what 1. So you do your normal multiplication for that one, and you get your answer. So they now told us that okay, we need to also remove this last item, and the last item is what? The circular shape of the pipe. So before, what we removed was the, what do you call it? Before, what we removed was the what? The length times the width times the depth, right? But this time we're removing the circular shape, to give us that accurate curve. So that is why it is now going to be what? The 0.55 times 0.55 times pi d pi all over 4. So that's it. Let me expose this one so you understand better.
That's cool.
So, yeah.
And please, can you go back to horizontal shortening of the roof? Like, I don't understand you got 1. I don't understand you got 1.5.
Please start with reduction of holes. Please, I was following through the circular area of circle and everything, but we got lost from that point. Thank you.
Okay, so for this deduct hole, the thing is that at first you have your normal plane surface, right? But when you are constructing, it's reasonable for us to know that okay, we have to remove that small area because we can't afford to say we want to be breaking the reinforcement, it will be weakening our composition. So now, and you're also calculating for efficiency and whatnot. So you have to remove this 550, Abby, and you know that this 550 needs to be multiplied by the depth which is working with, Abby. So that's what? This times this. So that's this times this times the pi that we are working with. Length times breadth times pi. Do you guys get it? Then for the horizontal shortening, that one is when you come to this idea now. For the horizontal shortening, that one is just from year to year. Like the actual, this one is small, is the one internal we're working with now, not the external one. The internal one, that's the horizontal shortening. This one from year to year, that's what 150 plus times, I say 150, 1,500 times from year to year, which is 1,000. When you convert it to meter, you have your 1.5 and you have your 1. That's how you get the horizontal shortening. Then you now go to deduct the last item. So I think it was intentional when they said deduct the last item.
Please, sorry, what's 0.786?
Pi all over 4.
Okay, pi all over 4.
Yeah.
Okay.
So the next is now you trying to what? You're trying to remove the circular shape from the from the manhole, right? So that would be what? 0.55, which is the depth times 0.55 times. So we are assuming that these are length and radius. I know its radius is pi r squared over 4. So that's pi times pi r times d all over 4. or d all over 2, whatever it is. But I use d all over 4, so it's going to be this times this times this. Sorry, my brain is already shuttering. They're almost done, though, Sha.
The 0.55 is not the diameter.
Yes, it's the diameter of this area. Let me show you. Yeah, diameter of where we want to place our pipe.
Okay. Okay, so while you said deduct the last item. So while multiplying 0.55 by 0.55.
Okay, why are we doing 0.55 and 0.55, Abby?
Yes.
Based on the material he gave us, right, I think why he's doing that is it is not just in one place. Do you get? It is exceeding from year to year to year. Do you get? Do you get what I'm saying? Normally, we were working with just this area, right? But it's exceeding this place to move to this outside here.
Oh, okay, all right. Thank you.
It's a two-way thing. It's either it is like that or it is what they call it, it's in two phases. But I couldn't picturize it, so I just had to let it go because of the short time I had. So the last one is what? Not the last one actually. We will now remove the vertical rough shortening. We already removed the horizontal, that's the surface, whatever. So the vertical shortening, shortening now. Shortening is just like what you use to support what you're doing. So now that one is going to be what? 1.95. So 1.95 is going to be, let me take it to that side. 1.15 is just going to be you adding kidney to this one. Adding 225, and you adding 225. Do you get what I'm saying? The horizontal shortening, you don't need to add 225 to this your 150. Just use 150 times 1. I keep saying 150, but you just need to add 1,500 times 1,000. Do you get? But when you're doing the vertical shortening, the vertical shortening is going to be 1,500 plus 225 plus 225, which is going to be what? 1,915. And so that's that for the length. And you do the same for the breadth. You get your answer. I could have just cleaned this one and just do normal one. You get?
Cool. That's cool. If you check your Excel sheet for the horizontal shortening, there was no time sync. But for the vertical, we have time sync of 2.
For the horizontal shortening, there was no time sync.
Yes.
And for the vertical, there was time sync. Excellent question. Honestly, I don't know why we had to multiply by 2, if I'm being honest. But if I'm to conceptualize on the spot, I think why that is the case is because the one I could study well was generator house. After when I got to the manhole, I studied it, but I couldn't afford to waste further time on it. So, but let's just see it together. So now, based on what I'm seeing here, why we are doing horizontal shortening for one is just from external like this, which is the internal one here, right? This is the internal one. But I think why we are doing external, why we are multiplying by 2 for external is because we are working with the total whatever, like up and down. Do you get? Up and down, side. But in this case, we are not working with that. We are working with just one, like the area straight. No now, see it now. Yeah, this 1.95 is from year to year. We are multiplying it by 2. That means 2 times this, that's 2 places, Abi. And this from year to year, right? We are also multiplying it by 2. That's from year to year, right? So that's automatically going to give us the area now. Like the perimeter of what you are working with.
Okay, so why didn't we take perimeter for the horizontal shortening?
Yeah, I don't know why, but demand didn't do that. It did area straight. It probably has his own bias. Don't know why. me being honest. Are we good?
Yeah, we're good. We're good.
Yeah. I don't know why. That means if that's the case, I probably need to adjust this answer. But probably later. And this one is just going to be this times this. How come I forgot to do it? It's just going to be this. It's just going to be 0.5 times this one. Do you get this one? This one is vertical curved shortening. So you just do, where is it now? What is it? B37 times A37. And for the last one, you do mild steel reinforcement with BEME. So the mild steel, like the mild steel are using to open up the hole and whatnot. So it's just going to what 0.55 times. This is a pi. Let me bring it out so you can see it better. Oh, so this is pi. Pi divided by 2. And that's our final whatever.
That last one, the 0 point something. The last one row. Yeah. Is it pi d? Is it like the perimeter of the hole?
Yeah.
Okay, all right.
Yeah.
Thank you very much.
Yeah, so on this note, I guess I've been able to shed more light on what the concept of BEME is. And I really hope you guys were able to pick one or two. Hopefully you get to go and do more findings, and probably there might be clarifications you might want to, like there might be more things you would have seen that I probably didn't see. I probably want to guide further on or something, sure. But that's it from my end. Let me just show you my last slide. Hey, whoa, I have a deadline. Sure.
Thank you very much, Fasasi.
All right, thanks, man.
Yeah, it's my pleasure. I'm trying to see if I have something else in my last slide. Oh, the last slide is just trying to say thank you and try to let you know that it was a group effort, like all of us coming together to do this, because I didn't do it alone yet. We're all doing it together. Thank you.
Any questions we have, we direct them, sir. Thank you very much.
Any words?
Any questions that we have, we direct them to your DM. Thank you.
Hey, no vex now. If you told me to Kini Lord, BEME Lord, we cannot go jack my other courses.
Do it for the greater good, sir. God bless you.
You will be fine. No, well, take care, everyone. Bye.
Wally, Jack for 2.
I think